everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve d square minus 4d plus 3 into y equals to sine 3x. Solution: given differential equation, d square minus 4d plus 3 into y equals to sine 3x. So now let's find order and degree of the given differential equation. Okay, we can write this equation as d square into y minus 4dy plus 3y equals to sine 3x. We know that differential operator d equals to d by dx, then d square will be d square by dx square. Now we can write the above equation as d square y by dx square minus 4 into dy by dx plus 3y equals to sine 3x, right? Now identify the highest derivative here. D square y by dx square is the highest derivative, so our order will be 2. And the highest power of the highest derivative is our degree. So here our degree is 1. So we are given a differential equation in operator form, right? Which is in operator form. F of d into y equals to q. By comparing these two, we'll get f of d and q, where f of d equals to d square minus 4d plus 3 and q equals to sine 3x. Now we need to find the general solution to the given non-homogeneous equation, right? Since it is in f of d into y equals to q, we call it as non-homogeneous differential equation. And now we'll use y equals to yc plus yp to find general solution, where yc is a complementary function and yp is a particular integral. We'll get yc using roots of the auxiliary equation of the homogeneous equation of the non-homogeneous equation, and we'll get yp using 1 by f of d into q, right? So let's find complementary function firstly using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, replace differential operator d by m to get f of m, which is equals to m square minus 4m plus 3. Then our auxiliary equation will be m square minus 4m plus 3 equals to 0, right? We can factorize this polynomial, which is equals to, fine. Now you can split minus 4m as minus 3m minus m plus 3 equals to 0. Then take m common from the first two terms, you'll get m times m minus 3. Now take minus common from the next two terms, you'll get minus of m minus 3 equals to 0, right? Now we are having m minus 3 in both the terms of LHS. So what we'll do, we'll take m minus 3 common from these two terms, and you'll get m minus 3 into m minus 1 equals to 0. Now equate each factor to 0. If you equate m minus 3 to 0, you get m equals to 3. And if you equate m minus 1 to 0, you get m equals to 1. Finally, you'll get m equals to 3 and 1, or m equals to 1, 3. Therefore, m equals to 1, 3 are the roots of f of m equals to 0, the auxiliary equation, which are real and distinct. Now we'll write the complementary function. We know that when two roots, say m1, m2, are real and distinct, then our complementary function will be c1 e power 1 root into x plus c2 e power, that is another constant into e power another root into x, right? So here our complementary function will be c1 e power 1 root, say 1 into x plus c2 another constant into e power another root 3, right, into x. Then yc equals to c1 e power x plus c2 e power 3x. Therefore yc equals to c1 e power x plus c2 e power 3x. Now we can find particular integral. We know that particular integral is given by yp equals to 1 by f of d into q. Here we are having q is of sine ax form, right? And yp equals to 1 by f of d, d square minus 4d plus 3 into q sine 3x for a equals to 3. If you compare sine ax with sine 3x, you'll get a equals to 3. Fine, now we are having f of d equals to d square minus 4d plus 3, right? And you'll get d square equals to minus a square. This is a formula, okay? D square is equals to minus a square, which is equals to minus, for a equals to 3, you'll get minus d square, which is equals to minus 9. That is d square equals to minus 9 is the value. Fine, now we'll see what we'll get with when we substitute d square in the denominator, that is in f of d. You'll get, replace d square by minus 9, you'll get minus 9 minus 4d plus 3, which is equals to minus 9 plus 3 is minus 6 minus 4d, right? Which is equals to, you can take, yeah, here which is not equals to 0, right? Since it is not equals to 0, then you will get 1 by minus 6d minus 4d, right? If you get it is equals to 0, if you get something after replacing d square, if you get the denominator to 0, then will not replace d square by minus a square, right? Since it is not equals to 0, so what we'll do here? We'll replace d square by minus a square. If you consider sine 3x as sine ax, then you'll get for a equals to 3. D square equals to minus a square will be formula. Or if you treat q as sine bx, then d square equals to minus b square will be the formula. Okay, here we are treating sine 3x as sine ax. That means in sine ax form. Fine. Which is equals to minus 3 square equals to minus 9. Then you'll get 1 by, we'll write the same thing. We'll just do the rough work to make it clear. Minus 9 plus 3 is minus 6 minus 4d into sine 3x, right? Now we can take some minus 2 common from these two terms. Then we'll get 1 by, if you take minus 2 common, you'll get minus 2 times 3 plus 2d into sine 3x, right? Minus 2 into 3, minus 6, minus 2 plus 2. Minus 2 into plus 2 is minus 4 into d, right? Now, just split this as some 1 by minus 2 into 1 by 3 plus 2d into sine 3x. You can write 1 by minus 2 as minus 1 by 2, right? Into 1 by 3 plus 2d into sine 3x we are having, right? Is equals to minus 1 by 2 into, now multiply and divide with 3 minus 2d. Here you're having plus, right? So what we'll do, we'll multiply and divide with 3 minus 2d. Simply conjugate of this. Not conjugate, we don't have any I here. Okay, simply we'll write 3 minus 2d. We'll multiply and divide with 3 minus 2d into sine 3x. This is equals to minus 1 by 2 into 1 into 3 minus 2d is 3 minus 2d by 3 plus 2d into 3 minus 2d. 3 plus 2d into 3 minus 2d into sine 3x. This is equals to minus 1 by 2 into 3 minus 2d by, here we are having denominator of a plus b into a minus b form, which is a square minus b square, right? Equals to minus 1 by 2 into 3 minus 2d by 3 square is 9 minus 2d whole square is 2 square 4 d square. Just write d square into sine 3x. Okay. Now we are having minus 1 by 2 into 3 minus 2d by 9 minus 4d square into sine 3x. Let it be. We'll continue this later. Now, actually I forgot to say one thing. Sometimes we'll write this as 1 by 2d plus 3, both are positive, right? Since both terms are positive, into sine 3x. Then what we'll do? We'll just multiply and divide with 2d minus, here you're having plus, right? So you'll use minus 3 by 2d minus 3 into sine 3x. Okay, both will get the same value from both of this. How? Let's see. Now, if you take minus common from the 2d minus 3, you'll get minus of 3 minus 2d, right? Minus 3 is minus 3, minus into minus plus 2d. You'll get the same thing by, I'll use bracket, okay? Here also, from the denominator also take minus common, then you'll get minus of 3 minus 2d, right? Minus minus plus becomes plus, minus by minus becomes plus, then you get 1 by 2d plus 3 into 3 minus 2d by 3 minus 2d. Right? And you can say Here you're having both are positive terms. Here you're having two positive terms, so you can write 2d plus 3 as some 3 plus 2d also. So you'll get the same thing. Okay. Fine. Now coming to this. Now take 9 minus 4d square and let's see what happens if we replace d square. We'll get 9 minus 4 into replace d square by minus 9. What we'll do here? We'll just replace d square by minus a square, right? Which is equals to minus a is 3. Then we'll get minus 3 square is minus 9. Right? Which is equals to 9. Minus into minus plus. 4 nines are 36. 9 plus 36 is 45. Right? Which is not equals to 0. So we can dare to replace d square here. Replace d square by minus a square, which is equals to minus 3 square equals to minus 9. Then yp equals to 1 by 2 into 3 minus 2d by 9 minus 4 into minus 9 sine 3x. We'll just replace d square by minus 9, right? We already know that this is not going to be equal to 0. Equals to 1 by minus 1 by 2 into 3 minus 2d by 9 minus into minus plus 4 3s are 36 into sine 3x, which is equals to minus 1 by 2 into 3 minus 2d by 9 plus 36 45 into sine 3x, which is equals to minus 1 by 2 into, we'll split this as 1 by 45 into 3 minus 2d into sine 3x, right? Then this becomes minus 1 by 2 into 45, 90 into 3 minus 2d, this is not 20, okay, this is d, into sine 3x, which is equals to 1 by 90 into 3 sine 3x minus 2 into d sine 3x, which is equals to 1 by 90 into 3 sine 3x minus 2 into find derivative of sine 3x here. You can write directly the derivative of sine 3x instead of writing d sine 3x under brackets. Right? This is equals to minus 1 by 90 into 3 sine 3x minus 2 into derivative of sine 3x is 3 cos 3x. Right? Which is equals to minus 1 by 90 into 3 sine 3x minus 2 3s are 6 cos 3x. Let's take 3 common from the two terms, then you'll get minus 1 by 90 into 3 times sine 3x minus 2 cos 3x. Right? 3 into sine x is 3 sine 3x minus 3 2s are 6 cos 3x, which is equals to 3 1s are 3 30s. Right? You'll get minus 1 by 30 into sine 3x minus 2 cos 3x. You can either write with minus or you can make it positive simply by multiplying both the terms with this minus. You will just take this minus inside the brackets, then you get 1 by 30 times or 1 by 30 into minus 1 into sine 3x, otherwise minus sine 3x minus into minus plus 2 cos 3x. which is equals to 1 by 30 into, firstly write the term involving positive sign, 2 cos 3x minus sine 3x. So we can write yp as minus 1 by 30 into sine 3x minus 2 cos 3x, or the positive term. Okay, yp equals to this one, or minus 1 by 30 into sine 3x minus 2 cos 3x. Now let's write the general solution using two yp's. Therefore, the general solution is given by y equals to yc plus yp. Then y equals to yc, c1 e power x plus c2 e power 3x plus yp 1 by 30. Firstly, we'll write for the positive term, that is having positive sign in front of fraction. You'll have 1 by 30 into 2 cos 3x minus sine 3x. Okay, or y equals to c1 e power x plus c2 e power 3x minus, for the negative, minus 1 by 30 into sine 3x minus 2 cos 3x. Okay. Or you can just write this as y equals to c1 e power x plus c2 e power 3x plus 2 cos 3x minus sine 3x by 30, or y equals to c1 e power x plus c2 e power 3x minus sine 3x minus 2 cos 3x by 30. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.